In this question, we have three charges, Q1, Q2, and Q4. As you can see, the values for Q1 and Q2 are positive, and Q4 is negative. So in the XY coordinate system, we have Q1 at the origin, and then Q2 on the x-axis, 0.02 meters away from Q1, and then Q4 is also 0.02 meters away from Q1, but it is at a 60-degree angle to the x-axis. So the question is, what is the next net electrostatic force on Q1? So something to remember when you say force, we have a magnitude and a direction. So the magnitude is how big is the number in newtons, and the direction can be either positive or x-axis or negative y direction or an angle from the x-axis. When you usually have 2D type questions, it is usually an angle. So let's look at the electrostatic forces on Q1 because of Q2 and Q3. And because we are concentrating on Q1, we only look at what is happening at Q1. So Q1 and Q2 are both positive, which means they repel each other. So at Q1, the force is to the left because it is away from Q2, and we name it F12, force of Q1 because of Q2. And then it has to be on the same line, so that's why it is directly on the negative x direction. So let's look at Q1 and Q4. You see that they are positive and negative, which means they attract each other. So since we are only concentrating on what's happening at Q1, that the electrostatic force between Q1 and Q4 at Q1 is towards Q4 because they attract, and that is F14, meaning the force on Q1 because of Q4. And I'm drawing it on the same line as 1 and 4. So this is not as simple as all the forces being on one axis, and this is in the 2D dimension. So let's look at the chart. Let's look at the x and y components of F. So if I draw a chart, we have a force, and we have an x component, and then a y component. So we have two forces here. We have F12, and the x component of F12, as you can see, is negative because it's in the negative direction. So I'm simply going to write negative F12. I'm not plugging in values yet. And what is the y component of F12? Because it is solely on the x-axis, there is no y component, so I write a 0. And let's go to F14. So for F14, there's an x and a y component, and you see that F14 is on the first quadrant. Starting when you look at where the arrow is starting, it's on the first quadrant. So both x and y components are positive. So the x component here, so if I draw a little triangle here, this would be my x component. So that is going to be positive F14 times cosine of 60 degrees. And then for the y component, you see that it is adjacent over hypotenuse, so it is going to be sine. And again, this is positive because both x and y components are positive here. So F14 sine of 60 degrees. And then these are just two vectors, so to add vectors, we can add the components of the vector. So this is the sigma, or the summation of the forces. For the x, we have minus F12 plus F14 cosine of 60. And then on the y, we have 0 plus F14 sine of 60. So this is my x component of the net force, and this is my y component of the net force. Now let's calculate the F12 and F14 values, the magnitudes. So we are going to use Coulomb's law. So F12 is K Q1 Q2 over R squared. So we have K, and this is Newton meter squared over Coulomb squared, times F1, and then times F2, divide by the distance between 1 and 2 squared. So this is 0.02 squared, and this gives us 1.15 times 10 to the negative 24 newtons. It's a force, so it is in newtons. Let's look at F14. We have 8.99 times 10 to the 9, that is K. Then we have F1 Q1 and Q4. Remember, these are absolute values, so it is 3.2 times 10 to the negative 19th. It's positive. And then divide by the distance between 1 and 4. The distance between Q1 and Q4 is also 0.02 meters. So that is squared. And that, as you can see, gives the same value as F12 for the magnitude. And then what we can do is find our Fx and Fy. So Fx here is, we plug in values of F12 that we found and F14 that we found. And if you do that calculation, you'll see that it is negative 5.75 times 10 to the negative 25 newtons. And then for the y component, we have 9.96 times 10 to the negative 25th newtons. So then what do we do is, now we have an x component and a y component. So to find net force, we use the Pythagorean theorem. So net force squared is equal to x squared plus y squared, and we take the square root. So that is negative 5.75 times 10 to the negative 25 squared plus 9.96 times 10 to the negative 25 squared, and we take the square root later of this. And you can see that if you plug in these values in the calculator, F net, so you take the square root of this value, it will be 1.15 times 10 to the negative 24 newtons. So this is the magnitude of the net force. And then what we can do is find the direction. So let's draw this x and y here. So if we were to draw the x and y components, so this is x, then we have y. You see that the x is negative, so negative here, and this is the value of 5.75 times 10 to the negative 25th. And then we go up, so because this is a positive value, so we go up this way from where you ended x So this will be 5.75 here, and then this will be 9.96, and the vector goes from start to finish. So the value for this hypotenuse is what we found as F net. Now let's find the angle. So this angle theta, we can use tangent, so it will be tan theta equals opposite over adjacent, so opposite will be 9.96 times 10 to the negative 25th divided by 5.75 times 10 to the negative 25, and then you take the tan inverse of this value and it should give you 60 degrees. So what is this angle from positive x counterclockwise? Which means this is positive x, so positive x, you go from counterclockwise until you hit your net force. So that will be 180 minus that theta. So from positive x counterclockwise, it will be 180 minus theta, so that will be 120 degrees, and that would be the direction.